So I mentioned a bunch of proxies basically by showing images, and we looked at the concept of isotopes. Let's now do it more systematically by looking at a beautiful table put together by the so-called Carbon Brief website, which is a fantastic source for information on climate, carbon cycle, climate change, and so on and so forth. Okay, so this is just to look again at the temperature reconstruction. Here now we are only going from about 70 million years ago to the future. So we still see the Paleocene, Eocene thermal maximum here somewhere. Blah blah blah. So this figure I'm showing basically because it's shorter, so you can see a few more things, plus it cutely puts together the future projections as well. So average global surface temperature difference again to the baseline of 1961 to 1990, and the end of the dinosaurs happened here, and tremendously warm temperatures happened in the recent period, not compared to 500 million years ago, which was a little bit warmer. And there is also other evidences of calcium carbonate depositions and so on, which relate to how circulation would have changed, climate would have changed, and so on and so forth. So this is called the hot house, and this bigger time period is called the warm house. And then there is a very clear evidence that from about 50 million years ago or so, temperatures were generally cooling and maybe stayed steady for a while and then cooled again rapidly. So the global warming, which is much cooler than here, is happening in this context of long-term cooling, but you can see the coming out of the last ice age, we have been warming, and then we are headed somewhere closer to these ranges. There are obviously, when you see these kind of reconstructions, you have to find the explanations for what caused these changes in the past and how that says something about where we are headed in the future, let's say in terms of the climate sensitivity. For example, when I said there was also increased calcium carbonate deposition here, that means the carbon dioxide amount in the atmosphere and in the ocean would have been very different. So considering plates and continents were moving. For example, this is the period when Andes and the Himalayan mountains got formed, and whether they had something to do with the cooling, because they can change climate. Before the Himalayan mountains and India butting into the Asian landmass, you can imagine that there was no monsoon. What does the monsoon do? Monsoon pours a lot of water, which would increase weathering and take out carbon dioxide from the atmosphere, which would be a simple explanation for this kind of warming. And then you come out of the last ice age, and then you go warming, and then you have the Holocene, and then we are always worried now about what's happening in the future. And the future, as we will see in the next section of the course, is projections are based on the so-called scenarios, so scenarios of emissions, how technology will change, how population will change, how renewable energy will come in, how bioenergy may reduce emissions, how agricultural emissions may be reduced, and so on and so forth. And you can see that in the so-called business as usual scenarios, where we don't do anything, the warming can get up to 12 degrees in the worst case here by 2300. How reliable are these models out to that limit? Well, the uncertainty is really from the assumptions you make in the scenarios you are creating. These are narratives about the future. Obviously there is a lot of uncertainty there, but you can see that there is a large range of temperature projections into the future. So what are the types of proxy archives? Corals and sponges. So we use the types of measurements, typical interval, typical time span, and description. So for corals and sponges we use isotopes, chemical properties, and growth rates. So those are the bands that corals record. They are typically at the scale of years. Time span is centuries, how long the coral lives and dies. So corals build their hard skeletons from calcium carbonate they extract from seawater. I don't know if I'll read all of these things, but basically corals are precipitating calcium carbonate out of the water and building their skeleton, and then they are providing symbiotic relation to a lot of algae, and then recycling oxygen and nutrients and creating a biodiversity. And they are like the rainforests of the ocean, so they store a lot of information. Glaciers, types of measurements, typically you look for glacier extent. Typical interval is of a year. Time span is hundreds of years. So mountain glaciers grow and retreat over time in response to climatic conditions, and so records of their length can be used as a climate proxy. Historical documents, they are historical time periods. They can be hours to days. They can record hundreds of years depending on which empire, which dynasty, which government survived. So direct and indirect information about the climate can be gleaned from historical documents. Ice cores. The types of measurements are isotopes, dust, accumulation rate, which tells you something about how warm or cold the temperature was globally, greenhouse gases that are trapped in the bubbles and their concentrations, time scales of years, and time periods of hundreds of thousands of years. Ice sheets and glaciers form from the accumulation and compaction of snow over thousands of years. Drilling down through the layers of ice to retrieve a core provides a cross-section of that accumulation and hence a timeline of snow buildup. Okay, lake sediments, physical, chemical properties, shells, pollen, insects, molecular fossils, and isotopes. Decades to centuries is the time scale, and periods of millions of years depending on how long a natural lake remains. Sediments are washed into the lakes and accumulate through time. Like marine sediments, lake sediments offer a variety of climate proxies. Carbon and hydrogen isotope analysis of molecular fossils like leaf waxes coming from the protective coat on the leaves of plants can be used to infer changes in the landscape and water cycle. So they are collecting runoff, sediments, amount of rain, how quickly sediment accumulates determines how much organic matter like sapropels get preserved, and lots of information. Loess is basically a fine dust that gets carried from one region to another, and that is related to rainfall amount. So it is dust accumulation, physical and chemical properties are used, molecular fossils are buried in them. They can offer information, time scales of centuries to millennia, and information can be recorded for millions of years. The formation, transport, and deposition of wind-blown silt, known as loess or aeolian dust, which means airborne dust, is closely linked to changes in climate. Okay, large dust deposits are recorded in dry periods. For example, during the Ice Age, when large portion of land were covered with ice sheets and glaciers. Okay, marine sediments. We already mentioned that. We use physical and chemical properties, shells, pollen, molecular fossils, and isotopes for centuries and millennia, with time records of tens of millions of years. Each year sees billions of tons of sediment accumulate on the beds of seas and oceans across the world. These sediments capture tiny clues to climate of the time, including microfossils such as foraminifera that we looked at, and molecular fossils such as leaf waxes. Isotope analysis of these clues can reveal information about the climate. Okay, pack rat middens. They record pollen, insects, plant remnants, bones, teeth, isotopes. We will see how this happens. They can work for decades with tens of thousands of years of information. Pack rats, also known as wood rats, construct debris piles that can be crystallized over time by their urine, preserving the contents of for thousands of years. So the urine has their dietary information, plant remnants, their teeth have isotopic signatures of their diets, the climate, etc. Amazing, right? These middens contain remnants of plants, bones, teeth, insect shells, and seeds that can be dated and analyzed for their isotopic content, providing climatic information. Rock outcrops, physical and chemical properties, shells, pollen, insects, teeth, plant fossils, molecular fossils, isotopes, millennia for timescales, and hundreds of millions of years. Okay, ancient sedimentary rocks provide the oldest archives of Earth's climate. As with marine and lake sediments, a number of different proxies can be measured in them. Seal pelts. We use isotopes in them for decades, and they record centuries to millennia of information. The fur and skin of seals have been used for thousands of years to make warm and waterproof clothing and footwear. These skins contain isotopes of elements such as carbon and nitrogen that seals accumulated from the prey they consumed. They are eating some diet, and that prey is giving them the chemical composition in their furs and teeth and bones and so on. The concentrations of different isotopes can thus indicate the structure of the food chain in the past and hence the environmental conditions of that time. Speleothems we already mentioned. We use isotopes and chemical properties, decades to centuries, tens of thousands of years. They are formed from the buildup of mineral deposits, primarily calcium carbonate. Okay. Tree rings, ring width, wood density, and isotopes. We already talked about this. Time scale of years, records of thousands of years. Trees. Some trees can live for thousands of years. They apparently can replicate their chromosomes without losing the so-called telomeres, or the end of the DNA, which is the aging process. So they are able to age very slowly and live for thousands of years. Some trees live for thousands of years. So the annual growth of a tree is typically recorded in rings through the trunk. Each ring has a light part, fast growth in spring and early summer, and a dark part, slow growth in late summer and autumn for each year of growth. The amount of growth and thus the width of the rings reflects the climatic conditions of the time. Okay, so let me leave this here and come back again to look at some more reconstructed past climate informations, and I can never cease to be amazed by how much information can be derived from the past. Of course, they are low in resolution, they can have uncertainties and so on, but the multiple proxies can be combined to reconstruct past climates very well in terms of vegetation composition, location of the plate, or changes in forest content, changes in species that were dependent on them, and so on and so forth. Okay.